Welcome to Podcast on TechNation. This is a series of podcasts focused specifically on the biomedical and HTM industry. Episodes will be added monthly. Listening to each episode is eligible for one CE credit from the ACI. At the conclusion of this episode, you'll be able to access a survey that will appear under this episode's title. You'll be able to download your certificate once you submit the survey. Before we begin today's podcast, I'd like to invite you to our fall MD Expo. We'll be in Dallas, Texas from November the 10th to the 12th. So please visit mdexposhow.com for event details and registration information. Podcast on TechNation would like to thank our sponsor, Multi Medical Systems. Since 1996, Multi Medical Systems has provided a comprehensive suite of solutions that help healthcare organizations manage their medical equipment more efficiently, ensuring optimal performance and cost effectiveness. Multi-Medical Systems specializes in skilled short and long-term temporary biomedical equipment technician staffing, medical device maintenance and repairs, endoscope and surgical repairs, inventory verifications, and certified pre-owned medical equipment sales. Their promise of quality is highlighted by their achievement of the ISO 13485-2016 international certification by AMTIVO. For more information, visit multimedicalsystems.com. In this episode, we are joined again by Frank Majerowicz, co-founder of FiberTech Medical.
Welcome back to HTM Insider. I'm your host, as you know, Sherelle with Multi Medical Systems. And today we have part 2 with Frank from FiberTech. If you didn't see the first episode, you might want to go back and watch it so you can catch up on this episode or listen to it. We're going to go into a little more detail on the endoscope itself and then how biomeds can affect cost savings and troubleshoot in the field, whether in a hospital, you're in an endoscopy center, or a surgery center. So Frank, welcome back to HTM Insider. So happy to have you back again. I know we got in so much conversation last time, so I'm glad to catch up with you again. But can you introduce yourself in case somebody didn't see episode number 1?
Yeah, absolutely. Thanks, Sherelle. And hello, everybody. My name is Frank Majerowicz, and I'm one of the founders and partners of a company called FiberTech Medical. I've been working with endoscopes now for 35 years, and pretty much not much we haven't seen as far as scopes go. So happy to be here and share some of our experiences with you.
Pretty amazing you started working on scopes when you were 10 years old.
Yeah, right? Seems that way.
So we were talking about all the parts of a scope last time, a flexible endoscope. We're just really focused on that right now. There's so many other types of scopes, but right now we're looking at large diameter scopes. So you're looking at your colonoscopes and your GI scopes. So we're going to jump in and show you which can be a very intricate and important part of an endoscope, the bending section. So Frank's going to show you some parts to it and break it down, and we hope that you learned something from this. So Frank, show them what a bending section is all about.
Yeah, so absolutely. There's a handful of critical components when it comes to an endoscope, and most of y'all in the field, you just see the scope as a black tube and with it on a handle, and you really can't appreciate what's inside that tube and what's inside that handle. And there's a lot of components inside of an endoscope, but the to Sherelle's point, the bending section is definitely one of the more critical components. And I'm going to hold up the tip of a scope here. This particular scope, you don't even get to see this because it has the bending sheath, which is typically covered on the very tip, 6 inches of the scope. And this is the portion of the scope that when you angulate the knobs, this bending section, the tip of the scope will angulate, so forth, in 4 directions, okay? Colonoscopes and gastroscopes are designed to angulate in 4 directions, up, down, right, and left. And the physician, to properly perform a procedure, they highly rely on the accuracy of the deflection of the tip. If it's not deflecting enough, if it's deflecting too much, if it's tight or if it's loose. All of this can affect the outcome of the procedure. So we always want to make sure that the everything's working properly, so that when the procedure front, they can have the best outcomes possible. So we're looking at the outer portion of the distal end of the scope. But if we were to peel this part even further, what you're going to find inside is this component here. This is what we call the bending section. It's the innermost mechanical part of the endoscope. So if this were inside the scope, this would be bending just like this. Okay. Um, so this mechanical piece is designed to bend in 4 directions. Okay, again, your up, down, your right, and your left. And it might be hard to tell on the screen here, but it's made up of 30 or 40 stainless steel bands, and each of those bands, and again, you probably can't really see it, but they're all held together with rivets. Okay, so it's a very mechanical, component inside the scope. So what happens over? uh, Yep, it is, and it actually moves a little bit like a slinky. If you remember when we were young and you let a slinky walk down the stairs by itself, it kind of has a similar feel to that when you put it in your hand. But what happens is over time, okay, just from normal wear and tear, this component that I'm holding, which you don't see in the field, it's on the inside of the scope, but this bending section will just naturally break down over time, okay? And that happens for a couple of reasons. So, when the scopes are made or repaired and put back together, this component here, almost everything inside the scope, is heavily lubricated to avoid friction during use. The lubricant they use is a graphite powder. So over time, from all of the bending and the moving and so forth, that graphite powder can shift around inside the scope. So pieces become less lubricated as time goes by, if you will. Um, so that's one reason that this starts to wear out. It starts to feel a little sluggish and it starts to feel tighter as time goes by. The other thing that happens is external trauma to the scope. Maybe somebody stepped on it. Maybe it was pinched in a door. And this inner piece can become damaged. It can become dented or pinched. And that type of damage will also affect the maneuverability of this particular piece. Okay. And last, what happens is fluid gets in the scope. So probably, we might have talked about this in episode 1, but the worst enemy to the endoscope is getting fluid inside the scope. And that's why leak testing is so important. We always talk about leak testing, but if fluid gets into the scope, it actually will wash away the lubricant, okay? That protects this, makes it bend smoothly. And now you're really in a situation where it's going to feel tight. It might even feel grindy, if you will, and it's just not going to bend properly. So all of these varying factors come together and result in, well, pretty much the same end result. It's not bending properly, and this piece needs to be replaced. Okay.
You guys will hear the physician or someone tell you that the endoscope is snaking. And that's one of the points that you can think of. Now you've heard this training, that might be what is going on inside the scope when you have that snaking that occurs. Now, Frank, we just talked about leak testing. And I know our biomeds out there, they're responsible for maintaining that equipment. And there's several different kinds of leak testers. I know some of you out in the rural areas might still be a leak testing manually, but if you're
Mm-hmm.
using an automatic leak tester, Frank, let's talk about PSI and how important it is for biomeds to make sure that they're testing that to, create enough positive pressure to what affect a negative result to get the endoscope to test. So can you talk more about leak testing and what the different type of leak testers are and what they should be looking for proper use, and is that machine working correctly?
Yeah, absolutely. And before we move on to leak testing, I'd like to make one more note about this
Okay,
bending
sorry about
section.
that.
So
Yeah.
I showed you the bending section. We talked about how it wears out and so forth, and how it may get damaged. But what I want to do is share with the group what can you look for in the field, okay, to determine if this is working properly or not. And to show you that, I'm just going to go back to the scope one more time that I have here in front of me, okay? So if you basically just pick up a scope and turn the knobs, okay, most of you have probably done that before, but as you're turning the knobs, okay, if you feel in the knobs that they feel extra tight, or sometimes as you turn the knob, you can hear or even feel some grinding in the knobs, okay? So tightness in the knobs, grinding in the knobs, that is an indication that this bending section could be damaged or starting to wear out. Okay. And then the other indication that you can look for is when you angulate the tip of the scope, you're supposed to have an exact radius, okay, an even radius perfectly aligned with the tube. And you can see with this one here, that tip is perfectly aligned with the tube. So this one is in good condition. If the bending section was damaged, you may end up seeing something like this, where the tip is articulating out to the side. So you can see what I have here, it looks crooked, okay? So when this bends and it's not aligned properly and it might be kicking to the left or kicking to the right, that also is an indication that this bending section is damaged or wearing out. Okay. So they're just two simple things that you can do in the field to check if this is working properly or not. Okay. So
Yeah,
just
and
wanted
before,
to share that.
yeah, but before we go on, it reminded me about something else, Frank, is articulation.
Okay. So talking about the angulation system, um, let's start at the top of the scope. So when you grab the scope and you hold the handle in your hand, there's four control knobs. And I'm going to talk about, again, since this is an important topic and really affects the usability of the scope. The angulation system actually starts up at the head of the scope at the control knobs. Okay, you have four knobs at the top. You're looking at up, down is the big knob, and right and left is the small knob. Okay, so these knobs are connected to the bending section at the distal tip by four wires that run through the insertion tube. So you have an up cable, down cable, right cable, and left cable. And basically, it's really simple engineering. As you turn the knob, you're pulling on those cables, which in turn are pulling on the bending section and causing the tip of the scope to articulate. Okay. So the first thing that happens with an endoscope, and this is something that is considered normal wear, even if they take the best care of their scopes, eventually every colonoscope on average is going to need at least one angulation adjustment per year. And if they use the scope often enough, it could need two angulation adjustments per year. So basically, what happens is over time, from the bending of the tube and from all the articulation of these knobs, those wires inside the tube will start to stretch. Okay, and again, that's when the scope needs to get sent in for a simple adjustment. Everything's tightened up on the inside, and the angulation specifications are set back to where they're supposed to be before the scope is returned. Um, so there's two ways in the field that you can tell that a scope is due for an adjustment. Okay, the first sign is that you'll have play in the knobs. Okay, so when you turn either one of these knobs, you really don't want to feel any play or slack in the turning of those knobs. It should be a 1-to-1 ratio. And what I mean by that is you turn the knob and you see movement at the tip. Okay, as this starts to wear out, sometimes you can take these knobs, move them back and forth almost a quarter, half of a turn, and you have no movement at the distal tip. That's a sign that those wires, those cables are stretched out and due for an adjustment. Okay. The second thing that you can check in the field is you want to angulate the scope, the knobs all the way, and you want to look at the radius of the turn. Okay. Now, might be too much to share, okay, in this video, but for instance, a colonoscope. Okay, the radius of a standard colonoscope is going to be 180 degrees in the up position, that's about 180 degrees, 180 degrees in the down position, that's about 180 degrees. So if this scope was due for an angulation adjustment, in either one of these, you might only be achieving, for example, 90 degrees or 120 degrees. Um, that's a sign if you can't get to 180 degrees in the up or the down position on a colonoscope, that's a sign that the angulations are worn out and need to come in for an adjustment.
And it's so important, Frank, because the doctors are expecting the endoscope to work properly when they're utilizing it. And when they're inside the patient, they're doing things like retroflexing and they need to see things at different angles. And so it's not that you want to send it out to spend the money, it's crucial to patient care and patient safety. Correct?
Yeah, it is crucial. And you're right. The physicians depend on the scope meeting those specific angulations. And if it's not, then it's making their job more difficult. Okay. Procedures can take longer. Okay. Um, and it causes them to over torque the scope and make different moves that actually puts pressure on the scope and other components of the scope that's not necessary. If that was angulating the way it's supposed to, um, everything works better all the way around, for sure.
100%. Gosh, we could do this all day long. If you are interested in learning more, or if you're an HTM manager and you want to bring this education into your shop because you're responsible for the endoscope fleet, contact us. And Frank, myself, the entire team, we're wanting to help you reduce cost, increase uptimes, and improve patient care. So we mean that sincerely. But let's go on, because I know we have a short amount of time. Let's go on to leak testing, because that's, I think, is such an important component that the people that are reprocessing the scope and the biomed team need to work together to make sure this equipment is working correct. Right, Frank?
Yeah, absolutely. And so for the proper maintenance of an endoscope and to ensure or to prevent damage, the most critical step that they can take in the endoscopy departments in the clinics is leak testing the scope. Scopes are airtight. There's over 100 O-rings throughout an endoscope. And the worst, again, I said this earlier, but the worst enemy to an endoscope is getting moisture or fluid inside the scope. Okay. Um, in most cases, when a scope gets flooded, you're looking at a 3 to 5,000 or sometimes more cost of a repair in that scenario. So leak testing is extremely critical to proper operation and to preventing large repairs, large dollar repairs. Um, I always inform users that a leak test should be performed after every procedure. Okay, you don't want to skip it. One missed leak, you can end up with a flooded scope, right? And there's two different types of leak testers on the market. I don't have anything in front of me to show you on this video here, but um, there's an automated leak tester. Olympus calls it the MU1. You've probably seen it if you've been up in the GI labs or SPD departments. It's a small box that sits on the counter, has a coily tube that comes out of it that connects to the endoscope. And then there's the handheld leak tester. Um, Looks like the cuff from a blood pressure cuff. It has a little bulb on it. You hook it up to the endoscope. You pump up to a certain position with the meter, and your leak test. You're pressurizing the scope, and you're performing the leak test. Okay, either one of those are sufficient. I really don't have a preference one over the other. Um, the key is no matter what leak testing method you utilize, the key is just to make sure that you're doing it properly. Okay.
And to our biomed friends out there, I've been in so many of the endoscopy shops. Sorry, I got a little bit of a cold. That little box is very similar to an air compressor in a way, right? It blows air. You can get it to blow air. That little connector that connects to the endoscope needs to be close enough to the sink to perform the leak test, right, Frank?
Yeah,
But what
Absolutely.
if water gets inside that little curly tube that you talked about and falls in the sink, right? And they take it out and they push water up inside the endoscope. You have to
Hmm.
remember that, like Frank said, water is the worst enemy to an endoscope. So I saw that one time. They pushed fluid into 10 endoscopes in one day because the hose was sitting down in the water and they just kept taking it out and damaging another scope. So it's super important. So I really want you guys to grasp this. And Frank, we didn't even talk about the fact that these scopes have CCD chips, and that has a lot to do with the water damage and the cost of the repairs, right?
Yeah, yeah, they do. And there's a lot of probably too much to cover on this particular episode here. Again, just like the angulation system, we could do a whole episode just on leak testing. Um, but there are, I think, the key points that everybody needs to keep in mind if you're not familiar with this is one, leak testing is critical. A scope should be leak tested after every procedure. Okay, and there are, it's not as easy as it sounds. There are certain things you want to keep in mind. You don't want to get the fitting wet or get the leak testing fitting in the sink. Sometimes with the 180 scopes, they come with a leak testing cap. They sometimes forget to put the cap on the scope before they put it in, submerge it in the water. Okay, they flood the scope unknowingly. Okay, accidentally. Um, keeping in mind during the leak test, it's critical to angulate the tip of the scope. Just like I showed you how the angulation system works, part of the leak test is you need to angulate the tip of the scope in all four directions during the leak test to make sure you properly are, checking for leaks or pinholes or things like that. So again, there's a lot to it. It's not as easy as it sounds. Um, and as Sherelle said, our information will be at the beginning or at the end of this video. So if anybody needs more information about leak testing, we're happy to send those steps out to you, and you can just reach out to us. Sherelle, you had mentioned the CCD camera. Okay, I happen to have one right here next to me. So, um, well, on the screen here, this looks like a bunch of jumbled wires. Okay, but if I come up here, this is the actual camera, and you can see how tiny. Here's my pinky, and you can see how small that is. Okay, so this piece right here is the actual camera that is inside the scope. And we're back to picking up the insertion tube of the scope here. This camera sits at the very distal end of the scope. Okay, so if you look at the tip of the scope, you'll see three lenses. The two outer lenses are for light, but the center lens, right behind that center lens on the distal tip of the scope, is where this CCD sits. Okay, it is the camera is encased. It's a fairly robust component. It can take a little bit of, knocked around and swinging around. But again, it's a good time to bring this up because what damages this the most is getting fluid inside the scope. Okay. And actually think about this. They get fluid in the scope unknowingly. They hang the scope up in the closet at night. And while the scope is hanging, this distal tip is hanging down like this. And the camera is hanging down with the distal tip as well. And where do you think the fluid's going to go? Down the insertion tube, into the distal tip. It puddles around the camera. And if any of that fluid seeps through the camera casing, you're going to damage the camera. Once a camera gets damaged on an endoscope, you're looking at the most expensive repair. If it goes back to the manufacturer, you're easily $11,000, $12,000 repair. If it goes to a third party, you're still looking at $7,000, $8,000 for that repair. So, um, yeah, the cameras are pretty robust until they come in contact with fluid, and then you know.
Yep. So Frank, after this scope has been leak tested, has been reprocessed, which HLD, high level disinfectant. These are not sterilized endoscopes that you would find in the OR. It needs to go into a drying cabinet, correct?
Yeah, that's correct. Um, and it's difficult in today, especially for a biomed, to keep up with um, all the new technologies, okay, and all of the new mandates on how to properly store an endoscope. If you go back when you and I first started in this industry, 20 years ago, 30 years ago, they would just hang scopes on a wall without even being in a cabinet, and that was okay.
Right.
Then they decided, oh, we need cabinets. The scopes need to be in a cabinet. Then a few years later, they decided, oh, the cabinets need to be ventilated. Okay.
Mm-hmm.
And then the
That's
cabinets were
recently. That's
ventilated, right?
yeah.
Okay. And now they decided that, oh, the cabinets need to be ventilated and we need airflow through the channels. Okay.
Mm-hmm.
And, you know, we're not here to debate any of those theories. Okay. But I just want people to know that's where they are now. So, and you're going to find, depending on where you are, what facility you're in, not everybody is currently running ventilation through their channels. That requires one of the newer style cabinets. These cabinets are now that they have all these features built into them, it's not uncommon to be north of $20,000 for a scope cabinet to
Mm-hmm.
store 10 to 15 scopes. So again, depending on where you are and where your facility is, um, they may or may not be running air, purging air through the channels during storage. Um, and some of your facilities may not even have ventilation in the cabinet yet.
Yep.
So, but just want to make people aware that all of these different options are out there. And the recommended practice now is to store the scopes in a cabinet. The cabinet should have ventilation, and the cabinet should have the ability to have constant airflow going through the channels. And the whole theory behind that is to prevent bacteria buildup inside the channels while the scope is in storage.
Yep.
And the other important thing to keep in mind is as a biomed goes into the scope room, if you need to pull a scope out for any particular reason, you might see, in most cases, tags hanging on the scopes. So the new another new part of the protocol, it's been around for maybe about a half a dozen years. They call it hang time. Okay, that an endoscope has a specific amount of days that it can hang in that cabinet, and if it's not used within that time frame, the recommendation is the scope is pulled out, reprocessed, and put back in the cabinet before it can be used. And I'm not sure, it varies from location to location. I've seen those hang times range from 5 days to 7 days,
Mm-hmm.
depending on the individual protocol that a location wants to follow. But it's somewhere from 5 to 7 days, and that's why you see those tags hanging on the scope.
Yep.
It's related to the hang time policy.
I want to jump fast forward a little bit, just because of our time frame here, and I think we need to bring. We could just do more and more episodes on endoscopes. Um, the tower. So I know biomeds are getting called for a number of reasons. First, let's talk about the back of the tower, Frank, and the fans, and how important it is to make sure that those all kept free and clear of dust and particles to work properly.
Yeah. Um, You're absolutely right. There's never enough time. There's so much to talk about each topic here, but um, you know, you, the fans are. It's really a good point you bring up. So when you look at the cart, you have the Olympus or the Fuji or the Pentax light source and processor. Sometimes they're combined into a single unit. Sometimes there's two different boxes there. But the light source itself, there is a fan in there, and that fan does a couple of things. It keeps the unit cool, obviously during use. There's also components in there that provide the airflow, for the functioning of the scope properly. And you would be amazed. One thing that you can do in the field, okay, is once a year the covers should be taken off of those light sources, okay. and you should blow out all the dust. And this is something that's overlooked. Okay, many facilities do not do that, and you get a few years down the road. And keep in mind, these light sources and processors, they're in use easily 5, 6, 7 years, being used almost every day. And if they're not properly maintained, that's where you're going to, find yourself having, unforeseen issues down the road, expensive repairs, and then just that panic mode when you have a busy day of cases, the light source isn't working properly, and now you're stuck. So one thing that we do and that we recommend that a biomed could do is you want to at least once a year, you want to take the cover off of the light source, okay, and you just want to blow out all the dust that's in there, and you will be amazed how much dust builds up inside of those units, um, not just on and around the fan, but even on the electronic boards, and all of the components inside there will be covered with dust.
Yep.
And we go into some facilities or get some of these units in for service that probably haven't been opened up in 5 years. And, there's a quarter inch of dust sitting on everything. And eventually, that's going to start to affect the operation of the unit.
Yep, 100%. I think it's something that's been overlooked in the field and why I want to bring it up to the HTM professionals out there. The other thing is, Frank, they get called to endoscopy for a blurry image artifact occurring. Can you talk about that and again what water could be doing to affect that and how biomed can go in there and troubleshoot um, during procedure, just before procedure? The pressure's on. How can they run in there and be the hero?
Yeah. So image issues are common, and probably one of the worst, probably the most panic situation you can achieve right before a case when you have no image, or the image is cloudy, or the image has a rainbow going across it, whatever it may be. If you're called and you need to come in and look at this. So, my advice to a biomed would be this: there's a couple of first things you should do. And everybody's heard this saying before, no matter what it is you're working on. Um, my first advice is turn it off and reboot. Okay. A lot of times it might have just been a bad connection. Okay. It could have just been a hiccup with the unit. And you'll be surprised. Just simply turn it off, disconnect the scope, plug the scope back in, reboot it, and see what happens. That's the very first thing I would do. Okay. And a lot of people skip that step. Okay. They're in a panic. They shut it down. They unplug the scope. They sit it to the side and say the scope is damaged. Okay. We get the scope. It's fine. So it could have been the connector wasn't seated right. So reboot the system, unplug the scope, plug it back in, turn it back on. That's step one. Okay. The next step is actually look at the tip of the scope. Okay. You'll see some glass lenses down on the tip of the scope. You will be surprised that there could be some buildup on one of the lenses, causing the image to be foggy, or sometimes cloudy, or dark, or whatever it may be. Um, and just by wiping the tip of the scope with an alcohol wipe, a little 4x4 alcohol pad, get down there, wipe it really good, and you'll be amazed at how much the image can clear up just from something as simple as that. Again, I can't tell you over the years how many scopes have come in and the complaint is, dark image, cloudy image. We get the scope and it's a dirty lens.
Mm-hmm.
So it's as simple as looking at the tip. And that's really the second step you should do. If you're caught into a room with a bad image, make sure the tip is clean, reboot the scope. There are two quick things you can do almost right away.
Now, let's say the light guide connector, there's a water bottle on this tower. It's coming out of being reprocessed. There's a lot of possibilities where there could be some type of fluid that is near the light guide connector or where it's plugged into. So, should they worry about, like we say, fluid's bad? Could that cause any problems?
Yeah, so yeah, and the last point, that is a good point that I will make about diagnosing an image issue. Um, when you disconnect the scope from the processor, you want to look in the connector, okay? Whether it be a 190 scope that plugs directly into the processor or whether it be a 180 scope that has the port on the side that you connect into, sometimes while the scope was being cleaned, some moisture or fluid could get into those connectors on those components. And inside there, there's electrical pins that need to have a perfect connection. If you get a little moisture or a little fluid in there, that's going to prevent the proper connection, could also cause image issues as well. So along with pulling out and rebooting, make sure you look in the connector, look at the pins, make sure they're dry and clean before you plug it back in.
Yep, 100%. Gosh, again, we could go on and on about scopes, Frank. It's been a pleasure having you on today. And again, I want to make sure that you understand that you can affect the cost savings and uptime to the endoscope equipment. Just take the time to learn it. There's a lot of information out there, and Frank is always available. He's great and his team to work with. We really loved having you on again today, Frank. Do you want to leave our guest with another wow, a word of wisdom today?
Yeah, I think it was a good topic to leave you with a financial wow today. So we talked a lot about fluid invasion today and leak testing. So I think the wow of today's conversation is if you leak test and you catch a leak in the bending rubber and you send it in, you're looking at a 300 and some dollar repair. Okay. If you don't catch the leak and you flood the scope, you could be looking at a $12,000 repair. Wow.
Yep. Wow,
That's a big difference.
exactly.
Yeah.
Exactly. Well, we're going to throw some information up when we post this for you to contact either myself or to Frank and his team. And if you have any other questions, shoot us a message. We're here. You can find HTM Insider any place you listen to your favorite podcast, including Apple Music, Spotify, YouTube, and of course, you can find it on the MMS website. Thanks for joining us again today, and we hope to see you next time on HTM Insider.
Yep. Thanks. Bye bye, everybody.
Thank you for a great presentation. Now, if you enjoyed today's episode, you might enjoy our ongoing webinar series, Webinar Wednesday. You can find a calendar of upcoming live webinars, as well as an archive of on-demand webinars at webinarwednesday.live. To obtain your certificate for 1 CE credit from the ACI, please remember to complete and submit the survey located below the podcast title. If you have any questions, you can reach us at webinar@mdpublishing.com.